Good afternoon. I'm here representing the team, the confused Electrons, and I'm here to present our proposal for the EPO Codefest 2024. Name, Optimizing Prior Art Search and EPO Search Report Generation using LLMs. I will give a brief introduction, talk about the problem statement, and present our proposed solution in a demo. We decided to focus our attention to one of the critical steps in the patent application process, the search report generation. This step is critical in the patent application process, but is also one of the most resource-intensive ones. The biggest challenge for a patent agent is the amount of information that they have to sift through. Searching from a huge volume of prior art with complex technical jargon, they have to distinguish one claim from another one to disentangle their meaning. And all of these has to be made for each patent application as fast as possible within a short time period, since the volume of application just keeps on growing. Our solution focuses on utilizing Gen AI models and large language models to try to improve the classification accuracy of patent applications and claims, and to automate prior art searches with the goal to assist the patent examiners do their job more efficiently and shorten the time it takes for a search report generation. Now, let's see what our solution looks like. Okay, so now I'll give a brief overview of the GitHub. So in the presentation and supporting documents, you can find a brief introduction with the slides to the project. And of course, this video and other supporting videos. In the source code, you can find the data preprocessing, the model training, and the data and the models. We provide the data and the models using these links. So the evaluation dataset and the embedding file that are needed to run the application. And also for the models, we provide the classifiers and the label encoder that will be required in the application. If you need to generate the data again, we provide a notebook in this data processing folder where you will go through a series of codes that will generate a full data set depending on the need. So you could query something different if you want to try some other classifications or some other dates from the EPO dataset. And since all of these uses the EPUB API, this can be different. So we already provide some to test the application, but you can also generate your own. Okay, so now for the demo code, the first thing we have to do is import the libraries, install the libraries, import all the functions, and we need to use a GPU to run this code. Otherwise, the program will not work. So it just requires one. Then we need to load the model. So in my case, the models are stored in my drive and also in the virtual machine for Colab. So you will need to change this directory here and here. And this one should be okay because this is coming from Hugging Face. So after you mount the drive, you load your classifier, you load your encoder, and you load your sentence transformer. You then have to use the load database. So this is the eval dataset that we're providing. And if you're not using this eval dataset that we provide, then you would first need to generate your eval dataset and also run the generate embeddings for this dataset that you want to use. Since this takes a bit of time depending on the amount of records. I suggest that you run this code with your dataset and you save those embeddings so you can load them later. In this code, we have set up the name so that you can load a dataset with this name, a val dataset. And then if you want to encode it, you will need to use this part of the code and then save it to whatever you want. So this one, just this cell in specific needs to be run only if you're not using the provided eval dataset and its corresponding embeddings, eval embeddings B3. But if you are, you can just skip ahead to loading the embedding of the database in here. And after that, we just check the evaluation dataset and we add the embeddings to a data frame. And in here, we're defining a program that we're going to use to run our prediction. So this cell will take the claims that the user inputs and will generate a prediction IPC code at the output. So if I run this program, I have a few claims to test here. So I can take this claim that I prepared earlier, and here you would put your claims. So, and you can enter one or multiple claims. I paste it here and I hit enter. And as you can see, the predicted IPC section is G in this case. And then I would try with another claim. And this is a different claim, so I would expect a different IPC code. And indeed, we get the predicted IPC section B. And once I'm done with my claim input, I would type exit here. And this will take a while to compare the similarities between the claims I inputted and the embeddings that we generated earlier. So we get the first similarity scores. Here I can see the content of my claim. And after that, I get the predicted IPC score and the top 10 most relevant prior arts and its similarity score. So I get the publication number and a similarity score. Usually anything above 0.7 is quite high. So I can take this 0.85 that seems to be quite similar. And I take this and I would copy the publication number to compare it later. Then we have the second claim that we inputted, the one that was predicted IPC code B, and the top 10 most relevant documents from the database that we're using, and also the similarity scores of each of the documents. Okay, so this is my dataset, my evaluation dataset. And with this one, what I can do is manually check the document number, the publication number, just to verify that the similarity score is actually close to what was inputted. So I put the publication number that I got from the tool, from the predicted 0.85 similarity. And if I run this, we can see it's quite similar. It was this one. So after that, we can save the results to a CSV. And if we read the CSV, we can see that we get the input claim that we were using, the predicted IPC section, and the relevancy score for each of the top 10 most relevant documents found in the prior art section.